Hi folks, thanks to be here for this talk about chopping the monolith. I'm Nicola Frankel, I've been a developer for a long time, and since a couple of years I work as a developer advocate. Right now I advocate for the Apache API 6 project, which is an API gateway built upon Nginx with OpenRuST on top and with a lot of out-of-the-box plugins. I will use Apache API 6 in my demo, but this talk is not about Apache API 6, so you are free to choose any gateway you want. Disclaimer, this talk might contain a lot of controversial views, and you are welcome to disregard any of them. The state we are in right now is very interesting, because on one side, we see a lot of people advocating for using microservices, in my opinion, for the wrong reasons. And on the other side, we see monolith viewed as something bad. I mean, the word monolith itself has taken up a negative connotation, which I believe is not completely justified. So I would like first to dive a bit into what is a monolith, but much more importantly, what are microservices and the reason they came to be used. I will use a lot of Martin's Fowler definition because, like, he's a respected figure and it's not very controversial what he says. It's he plainly states facts, and so we can reuse them without much debate. So here I let you read the definition of Martin's Fowler microservices on his own Blicky. I'll leave you a couple of seconds to do that. And the gist of it is, well, you have each microservice running in its own process. That's the gist of it. And in the same article, he goes on to follow a couple of characteristics of microservices. And the interesting thing about those characteristics is that they happen at different, let's say, levels. So, for example, some of them are very technical, some are more organizational. And let's play a game. I know that we are not interacting, but please think whether you are using microservices or not in your organization. Okay, now that if it's done, and if the answer is yes, you can go through each item and check whether it's the case or not. So are you if you are doing microservices, are you using componentization via services? Is each of your service organized around business capabilities? And so on and so forth. And at the beginning, there are more technical approaches, and I believe everybody implement them if you are doing microservices. However, at the bottom, there are two parts that are more organizational. And the most important one is product over projects. If you are doing microservices, you are not designing projects, you are designing product. The difference between a project as a start date and an end date, and you have a budget that needs to be spent between those 2 points, whereas a product has a start date, but there is no end date at the beginning. There will probably be an end date at some point when you retire the product, but you don't think about it, you don't plan for it, and the budget is probably recurring over several years. And that's the problem. A lot of people who claim they are doing microservices, they are still doing projects and not products. Hence, there is not many chance a lot of people among you are really doing microservices. In general, when I do this talk in a room of 50, I ask people who are doing microservices. There is half the room that raise their hand, and when we apply all those characteristics, in the end, there is probably 1 or 2 persons still doing that. So 1 or 2 person in general, that's the biggest problem, the product side. Okay, but it doesn't stop at that. when I started to read about microservices, a lot of people, a lot of the advocates of microservices were keen to point out Conway's law. And Conway's law is very simple. In his thesis, he stated that the architecture of an information system reflects how the company, the organization is itself structured. So the idea is that if you start with like a normal organization with, let's say, UI specialists and middleware specialists and DBAs, you will probably end up with a layered architecture because you will have like each team doing their own stuff. So if you want to have microservices, then you should probably like change your organization to have like autonomous, independent teams. And for example, Amazon Web Services is a poster child for microservices because Bezos himself like told, hey, we have these 2 pizzas teams. So basically we have teams that can be fed with 2 pizzas. And it means they are like small and of course implying they are autonomous and independent. But my beef is that actually a very, very few organizations are like that. It's probably the case for like 1% or 0.5% of the organization, because most legacy organizations are designed around silos. So at the top, you've got the CEO, then you have the CTO, then in general, under the CTO, you have developer and operation. And in developer, you have like dedicated team, and in operation, you have other team. Then you have that silo between like dev and ops. So that's the reason for the DevOps. And again, in each like team, in the development team, you probably have a manager that manages the planning, the schedule, that gives out tasks, that handles the Jiras, whatever. And it's very hard to move from like such an organization designed around like silos to a team, to teams that are autonomous and independent. And the biggest problem, of course, are if you have a manager for each layer, for each like old legacy like silo, what do you do with them in the new organization? I always joke, and it might not be such a joke, that if your manager is like responsibilities is like to accept your vacation requests, to be a proxy for the pay raise each year, because let's face it, you cannot negotiate. It's just like a top-down decision, and do some reporting, then probably I don't need a manager, because I'm more already oriented toward the self-autonomous team. I know what to do. You give me a goal and I will achieve it. I don't need to be micromanaged. And actually, probably if you are working in an organization with manager, either they micromanage you, then they work a lot, but they don't add any value because you probably know better than them what you should do. Or they leave you free, or then probably again, they don't have a lot of value because we go back to the accepting vacation request and being a proxy and report it. Manager have a lot of value when they actually remove the roadblocks into removing removing any impediment you have toward your task. Otherwise, not that much. And so we get back to this issue where actually the biggest help into transforming a legacy organization into a microservice based organization is the middle management. And they are the ones that have the most to lose because they won't have any place in the new organization. So it's a pretty bleak picture. But the problem is that in most microservices implementation, it starts with the technical side. You've got a a technical person, probably like very senior, and they read about microservices and they see all the benefit and they say, oh, I have all this problem in my architecture, in my organization, like microservices seems to solve them. Okay, let's do that by the book, and we will remove transactions and we will have sagas and whatever. And then at some point, of course, the organization is not made for that. The organization is not designed for that. There will be a mismatch because of Conway's law. So you will end up in a situation you will have all the downsides of microservices and none of the benefits, which doesn't work that well. At that point, in general, the person who had the bright idea to implement microservices has already left for another job. And of course, they didn't forget to put microservices on their resume because, yeah, it's super shiny. And the problem is that our industry is an industry where we are supposed to have technical people, logical people, engineers who generally take decisions based on facts. However, my experience has shown me that most of the time, it's more like a herd of sheep following somebody who say, hey, like, follow me. I have the solution for every one of your problem, and we are following. And it's not that great. Also, not to mention the fact that probably a lot of people want to put some line on their resume. And as an anecdote, like 15 years ago, I worked on I didn't work on a project, but I worked in a place where the project next to me, they were implementing EGB3. And at the point EGB3 was like state of the art. The problem is that at this moment, there were no application servers, like production grade, let's say, based on some big companies like IBM, for example. And IBM was the normal provider of technologies in this organization. The product was not ready to run EGB3. So basically, the architect decided, hey, we will use EGB3 so that he could write it down on their CV. And it was not implemented in real life. There was no production application server ready to run EGB3 at that time. So I don't know what happened, but that's a poster child for a very, very wrong decision. So why are people still doing microservices? If microservices are not the right thing, why are people still using it? Well, in another one of his articles, Martin Fowler describes a couple of benefits. Of course, there are costs, and we won't tell about the cost because I believe that nowadays everybody knows about the cost. He lists a couple of benefits, and there are three main benefits: strong module boundaries, independent deployment, and technology diversity. So let's talk about them each in turn and see what is the real benefit. So a lot of people say, hey, now if you implement microservice, of course, then you have a strong boundary between service, then you cannot reuse, or at least say, it should prevent you as much as possible from reusing the code from each other and then having entanglement in your code base. And that's true. But actually, there are other ways in each different tech stacks to implement those strong module boundaries. For example, in Java, you can have Java modules, or you can have let's see, there are some ways to say, hey, this package should depend on this package and not on this package, and then have an engine that checks that those rules are respected. And you can have your dependency graph between packages, and you can see it a lot. Of course, it will be after you have actually implemented the code, but with some discipline, it will work in exactly the same way. And again, if you want it to be at compile time, just implement Java modules and you should be done. In each tech stack, you probably have the same ways to do that. So other ways to do it, and with much less problems to boot. So it's probably not the right reason. It's a benefit, but it's not the reason. Technology diversity. Well, if you have microservices, of course, you can implement each of the service with their own tech stack. So you can have a Python microservice, a Node.js microservice, and aside a Java microservice. Everybody will be happy. And when I mean everybody, that's probably every developer, because then every team can choose their own technology, what they like the most. The problem is it works at the level of the team or at the level of a person, but probably not at the level of organization. Because if you have an organization of 200 people that really have already trouble recruiting good developers in one single tech stack, how would you recruit more developers in other tech stacks? I don't believe that you can take a Python developer and presto, you make it into a Java developer and vice versa. I'm a Java developer. I know Kotlin quite well at the moment, but I can write Python scripts. I'm unable to be like a good Python developer. I lack too many years of experience. I can be a junior one. I cannot be a senior Python developer. I will probably write code that works, but not code that is Pythonic. And so for this reason, again, not the best of reasons. However, I think that independent deployment is the real reason. It's the real benefit. And you might have heard about lead time, which is one of the golden metrics of DevOps. So if you have a project and it starts with the idea from the business and it ends with the deployment into production, you probably have those three phases like specification and implementation and deployment. So specification starts with the idea of the business until you've got the whole set of specifications. And to be honest, it's hard to do anything about it. It involves a lot of communication with the business. Depending on the maturity, you might have a lot of feedback loops. Right now, if you are doing Agile, probably you have a lot by design because the business doesn't know, and actually that's pretty true. However, when we want to deploy more rapidly, we probably want to shorten the implementation and deployment phase. And those two are the lead time. And this problem of deploying more frequently or deploying faster, it's not a new problem. We already had it back in the days. As I mentioned, I've been doing IT for nearly 2 decades, no more than 2 decades. And so I actually can vouch for the fact that we handled it before. So let me get back to it. So perhaps you have gray hair like me. If not, please bear with me because it will sound super, super funny. So back in the days, we didn't release frequently because releasing frequently would need, every time you would need to test the whole stuff. And we didn't have automated tests, or at least perhaps some unit tests, but no integration tests. So a lot of it was manual testing, and through manual testing, it cost a lot of time, a lot of resources. It tires the testers, and testing everything too frequently is not feasible. So we had a couple of releases per year, let's say 4 of them. And those releases were called release trains. And so the idea was you would design your code or your project so that it would fit at the date of the release train. And if you missed the train because your developers were too busy, too late or whatever, then you would need to wait until the next train. So if you deploy 4 times per year, it means that if you cannot ship a feature in train, you need to wait 3 months. And for the business, 3 months is a long, long time. So you were not allowed to miss the train. There was a lot of pressure to deliver on time, even if it was half finished, because the trick was you could send a bug fix directly to production without doing the whole testing, whatever. So the trick was actually to pretend to have finished one feature. And then, of course, it was not completely ready, or you knew it contained bugs, but then you could send the bug fixes afterwards. And sometimes it was even worse. You had a not finished design feature at all, but you would negotiate with the release manager that, hey, it was a bug fix, and it was, again, a lot about organizational issues. And though, as I mentioned, it's not possible to release often and test monolith well. You cannot do everything at once. It's not possible. And for this reason, release trains. Now let's focus on what I believe is the real problem. I believe that yes, some parts of the code do change frequently or at like frequency you cannot fathom. It can be because of laws. I mean, laws you cannot like plan for them. They will just happen. Of course, if you are a big organization with a lot of money, you can influence the laws, but I'm talking about regular organization. Regular organization, their software can be impacted without any influence from them because of laws. Sometimes it's because of the business that say, hey, I want this to change and I want this to change, and the same thing over and over. And I believe that every software has ports that change with different pace. Some parts are very stable. Some parts are very unstable. And with a bit of habit, people who work on the code base, they know it. So again, let's say to like be easy, ports that like very, very rarely change and ports that change very often. And in the past, to handle the fast changing pace without redeploying everything, we had something called rules engine. And with rules engine, this is the definition of Wikipedia, you actually had code that was explicitly separated from the main application code. And so you released once, so there was no release, and then the business had an interface to change the rule directly in production, and they could do it whenever they wanted. And of course, with great power comes great responsibility. That was their responsibility who handled changes. And if they did write some bugs, it was their problem. But I don't believe that rules engine are like the solution. It's one of the solutions. For example, once I didn't like work on any like rules engine implementation, but I had the occasion to like read the code of one once because I was curious. And actually, the code, the rule itself was so complex that if you were not a developer, you had no chance of changing it. So the idea that the business can do that on their own is, I think, a bit hard. And if you were not from the business, it was very hard to understand the business logic if you were a developer. So you had to have both skills at once. Nevertheless, I think that the idea that you have like different parts of the code that change at different paces, it's still very like solid. It's a fact. And so rules engine are one way to change that, to cope with that, but there are other ways. You can have microservices, you can have serverless, you can have anything you want. And in Chris Richardson microservices pattern, so Chris Richardson has written a book about microservices, how you can like implement everything from the technical side to implement microservices. And he has also designed a site where you have design patterns for microservices. He goes on to describe how you can like evolve from one monolithic architecture to one like microservices architecture. And he uses the strangling fig pattern that also was described by Martin Fowler. And the idea is that you start with a monolith and then you go on like chopping like every part until you've got a microservice architecture, like one by one. And the problem with that approach is that, of course, he's describing a microservice architecture. So in the end, there is no monolith anymore. And I believe it's perfectly fine to start with a monolith and to stop at any point where actually the fast changing part have been isolated, where the non-fast changing part can stay inside the monolith. Because again, microservices architecture, you need a dedicated organization for that. Not everybody is prepared or is like this. So imagine you have an application that actually is a monolith and you want to chop apart. This application is a web application. One of the ways to handle that is through an API gateway. So you could have like the whole application going to the monolith through the API gateway, and because in some parts, so some path would be actually be directed to the chopped path. Imagine an e-commerce shop. And the business, I've worked in e-commerce before, business want to push some product. It might be for a lot of different reasons, like too much stock or flagship product or high margin product. I mean, lots and lots of reasons. In general, you sell more and by lowering the price, so that the pricing should be very, very flexible. If you have a rules engine pricing, it works pretty well. If you have defined every parameter that could change, for example, you can say, hey, this is a flagship product. If this is a flagship product, then do something. The problem with rules engine is that the code from the main application should match the code from the rules. The parameters need to be defined in advance. If you come up with a new parameter, of course, then probably the monolith part needs to change as well. So pricing should be flexible. In that case, the rules engine might not be a great idea. So the idea is we set up an API gateway, we don't break the client will stay the same, and we can like deliver like flexible pricing without any issue. So for that, I have a demo. So here I'm in IntelliJ. I've set up everything in Docker Compose because it's the easiest way to show you something. Of course, you shouldn't use Docker Compose in production, but for this demo, it's good enough. So here I have a couple of services. I have the API 6 Apache Gateway. API 6 relies on etcd. It stores its configuration in this like distributed key value store. You might have heard about etcd before. It's the same key value storage that is used by Kubernetes internally. So it's quite like major and very hard to break. Then I have my application, which is an e-commerce application. I will show it just afterwards. And everything is stored in a MariaDB database, but that's not really important. So let's try our application. Okay, so Docker Compose up. So now Docker Compose starts every container. I've like containerized already the e-commerce shop. It's a Spring Boot application. This is not important, but everything is on GitHub, so you can check afterwards. And we will wait a bit until it has finished because it's a JVM. It takes a bit of time to start. And let's see for a couple of seconds. And yeah, it's done. So now we can go to the application. And here I've started the application. I go through the API gateway. And of course, the API gateway tells me, hey, like we don't know this path. So the first thing I need to do is configure the API gateway to like let it know about where it should forward this path. For that, I'm using Apache API 6, as I mentioned, and Apache API 6 as an admin API that is based on a REST API itself. So here I'm using a Docker image that should run on the same network as the Docker Compose. I'm using the curl image. So the idea is I'm not using curl directly, so I don't force you to install curl. If you have Docker, you can run everything. And there is the root API, and we will create a new one with put. We need to test the API key because like changing the configuration is a highly critical operation. So we need to be authenticated, but since it's a demo, I'm using the default key. And now we can create like this. So in this demo, I will catch every URI and I will send it to the chop shop. I have one single node, so I need to like have an algorithm, but since I have a single node, every algorithm would work. So I run the script, done. And now if we get back to the application, now we can see our shop. So we have a couple of products. We can set like add to cart, a couple of products, and then we can check our cart. Now this part is interesting. This part is actually, we've got, sorry, I need to refresh. Yes, I have a single request, like the pricing is embedded. So I have a single request to get the price. The price is computed like on the back end, and when I receive the result, I receive the result like with all the lines of the cart and the price in one JSON like payload. What I need to do now is to start changing it so that instead of like doing this, my client will receive the cart and the client will request to the application, to the monolith, hey, give me the price for this cart. So here is the pricing. As you can see, it's Kotlin. So I hope that my explanation will be good enough if you are not a Kotlin developer. Here I have a function, you pass it to cart and it computes the price, and basically it just adds everything. But the idea is that you can change this logic. And this pricing is used here. So when I request the checkout, it will like compute, it will get the cart itself plus the price of the cart. Again, as I mentioned, everything is computed server side and everything is returned as one entity called checkout view. So now the idea is we need to change it a bit, and for that we will expose the pricing as an HTTP route. So now the checkout view just returns the cart itself, but the pricing now is a dedicated HTTP route. So price will be like returned when you call the price endpoint. We need to containerize it. So it will be version 1.3 of the container, and we will deploy it again. So Docker compose up. It recreates the chop shop. And normally at this point, I should be good to restart the class loader. So here you can see the new like version of the application is starting again. Couple of seconds because it's a JVM. And yes, now it has started. Now we can go back to the application. So now it's a new like session. I've lost all my sessions, so I need to do the same as before. You can notice that here it's 1.3 and not 1.2. Same products, we can add everything to the cart and check the carts. And now again, I need to refresh because it caches the JavaScript. So if I refresh it, now the price is computed correctly, but there are two calls. The first one returns like we get the content of the cart, and with the content of the cart we call this price endpoint with the content of the cart. So the request contains all the lines of the cart and the response contains the pricing. Now what we can do is the next step, the final step, is actually to like intercept this /price call. And instead of forwarding it to the monolith, we can forward it anywhere. I will be using like a serverless function. So here I've created a JavaScript function. This JavaScript function, I've like uploaded it to Microsoft Azure function. And there is this new like change. So I will route it. I will create a new route. So like a new one that only intercept /price, and that through a plugin, because API 6 like natively understands how to talk with Azure, we can send it to a function array that I previously created. And I need an authorization token, and let's do that. So I can show you the Azure function. So here I'm on the Azure portal. I can go to function application. You see here I have the chop shop pricing, And if we check the code of the chop shop pricing, here is the function, here is the trigger. And we can see that the code that I've shown you in my IDE is the one that is displayed here. Again, Cloud takes a bit of time every time. And here, this is exactly what I've shown you before. So this code has been deployed. And now I will configure Apache API 6 to intercept the call and to direct the /price stuff to this function. Done. And now, if I get back here, I can refresh. The result is exactly the same. If we check the logs, we can see that actually here I have a log about pricing computed from a monolith, and here I have nothing of the sort. So the pricing was actually not computed by the monolith, but by my function. And the good thing about this is that I actually didn't need to deploy a new version of my monolith. So the monolith can be released at any point in time in the future without the chopped part, but for the moment it can stay as it is with no issue. And that's it. Thanks a lot for your attention. You can read my blog, you can follow me on Twitter. If you're interested to redo this demo at home, you can do it. The code is on GitHub. You need just to change the path and the authentication key for Azure so that you can actually use your own and not mine with my key. And if you're interested also about having another channel, I've written this talk in a blog post, and so please read it. Again, thanks a lot and have a good day.